Ingress NGINX Kubernetes Vulnerabilities. Introduction. Ingress controllers play a crucial role in Kubernetes environments, providing external access to services within a cluster. Among these, Ingress NGINX is one of the most widely used controllers. However, as with any software component exposed to the Internet, it is susceptible to security vulnerabilities. This lecture will cover common security vulnerabilities in Ingress NGINX, real-world examples of exploitation, code demonstrations, mitigation strategies, understanding Ingress NGINX architecture. Before diving into vulnerabilities, let's understand the architecture of Ingress NGINX. Ingress Resource defines routing rules. Ingress Controller implements the routing logic and interacts with NGINX. NGINX configuration, dynamically generated based on Ingress rules. When a request is made to the cluster, it is received by the Ingress NGINX controller, which then forwards it based on the rules defined in the Ingress resource. 1. Common Ingress NGINX vulnerabilities. 1.1. Request smuggling vulnerabilities. Example: attackers can exploit improperly handled headers to bypass security checks. Example code. How it works. If NGINX does not properly parse headers like transfer encoding, chunked, attackers may craft HTTP requests to smuggle malicious payloads. Mitigation. Enforce strict header validation in NGINX configuration. Set ignore_invalid_ headers in the NGINX configuration. SSRF, server-side request forgery. SSRF vulnerabilities arise when an attacker tricks the Ingress controller into sending requests to internal resources. Exploit scenario. An attacker crafts a request targeting an internal API. Mitigation. Block external access to metadata endpoints using policies. Regex injection in annotations. Ingress NGINX allows regex-based path matching, which can be exploited if improperly sanitized. Vulnerable example. An attacker could send a request like mitigation. Disable dynamic regex unless explicitly required. Sanitize user input to prevent injection. Real-world exploit demonstrations. Exploiting request smuggling. 1. Deploy the vulnerable Ingress resource. 2. Use burp suite or curl to send a crafted request. Exploiting SSRF. 1. Deploy a vulnerable Ingress configuration. 2. Send a request to access internal services. Best practices for securing Ingress NGINX. 1. Use minimal privileges. Ensure Ingress controllers do not run as root. 2. Restrict annotations. Limit dynamic configuration options. 3. Regularly update NGINX Ingress controller. Patch known vulnerabilities. 4. Monitor logs. Enable logging for suspicious patterns. 5. Enable Web Application Firewall. WF block common attack vectors. Conclusion. Ingress NGINX is a powerful tool but must be secured to prevent critical vulnerabilities. By applying best practices, monitoring, and proper configurations, Kubernetes administrators can mitigate risks effectively. Next steps. Perform a security audit of your current Ingress configurations. Implement the mitigation techniques discussed. Stay updated on new security advisories for Ingress NGINX. By following these security guidelines, you can ensure your Kubernetes applications remain protected against evolving threats.